We are now going to go over 4 examples where we're going to differentiate a function using the chain rule. Up here on the right in green, I've placed the formula for the derivative of our composite function f of g of x. The derivative then is just the derivative of the outside function times the derivative of the inside function. In our first example, in addition to using the chain rule, we are going to also use the power rule. Our derivative is then capital F prime of x is equal to the derivative of the outside function, so that's 3, 2x to the 4th plus 5x squared, and then we subtract 1 from 3 and get 2, and then we're going to multiply that by the derivative of the inside function. And that derivative is 4 times 2 is 8, x cubed, plus 5 times 2 is 10x. Now let's go ahead and simplify. Notice in this expression right here, we have a 2 that's common to both terms, and we also have an x common to both terms. So let's go ahead and let's pull that out and let's rearrange some terms. So this is 3 times 2x times 2x to the 4th plus 5x squared squared times what remains after we pull out the 2x, and that's going to be a 4x squared plus 5. When you're taking a derivative using the chain rule, it's customary when you write your final answer to write your answer as your constant first, and then smaller powers of x, and then bigger powers. So we are going to rewrite our answer as 6x times 4x squared plus 5. We're putting that one first because it's raised to the first power, and then we're going to put down 2x to the 4th plus 5x squared quantity squared. And then that's our final answer. Let's now look at our second example. In this example, in addition to the chain rule, we are going to use the power rule and the product rule. Our function has 2 terms, which is why we're going to need to use the product rule. Here's the first term, and then here's the second term. We're going to write our derivative f prime of x as our first term, x to the 4th minus 1 quantity cubed, times the derivative with respect to x of our second term, x cubed plus 1 to the 4th, plus our second term, x cubed plus 1 to the 4th, times the derivative of our first term, x to the 4th minus 1 quantity cubed. Now we're going to use the chain rule. We have the first term, x to the 4th minus 1 cubed. Using the chain rule for this derivative, we bring down the 4, and then we have an x cubed plus 1. Subtract 1 from the 4, and that's 3. Now we have to multiply by the derivative of what's inside, and that is 3x squared. Now let's go to the second piece. We're going to add x cubed plus 1 to the 4th, and then we use the chain rule and take the derivative of x to the 4th minus 1 quantity cubed. So we bring down the 3, and then we have an x to the 4th minus 1 squared, and then we multiply that by the derivative of what's inside, which is 4x cubed. Now we have to simplify all of this. I think it's easiest if we simplify both terms first and then see what combines. Our first term is 4 times 3, so that's 12. We have an x squared, and then we have an x to the 4th minus 1 cubed, and an x cubed plus 1 cubed. And then for our second term, we also have a 4 times a 3, so we have 12, and we have x cubed, and then we have an x cubed plus 1 to the 4th, and then x to the 4th minus 1 squared. Now let's see what both terms have in common. They both have a 12, so we can pull the 12 out. And then they both have an x term, And we can only pull out the lowest x term, so that's going to be x squared. So we pull out x squared. And then they both have an x to the fourth minus 1. And we can pull out the lowest power, which is a squared power. So this is x to the fourth minus 1 squared. And then lastly, they both have an x cubed plus 1. And we'll pull out the lowest power, which is a 3. So this is x cubed plus 1 cubed. Now we have to see what's left. In our first term, we're going to have one more x to the fourth minus 1. And then in our second term, we are going to have an extra x. And then we are going to have an extra x cubed plus 1. Let's go ahead and let's simplify this part. This is x to the fourth minus 1 plus x to the fourth plus x. So this is 2x to the fourth plus x minus 1. And we're going to combine all of this with this. This gives us an answer of 12x squared times x to the fourth minus 1 quantity squared times x cubed plus 1 cubed times 2x to the fourth plus x minus 1. And that took a while, but that is our final answer. For our third example, I chose a function that is going to require us to use, in addition to the chain rule, the power rule and the quotient rule. Notice that our function has a numerator and a denominator. So that clues us in that we have to use the quotient rule. Let's go ahead and take the derivative. F prime of x, using the chain rule first, is 5 times x squared over x plus 1 to the fourth. That's the derivative of the outside function. And then we're going to multiply this by the derivative of the inside function, which is our function that has the two pieces, x squared and x plus 1. This is equal to 5 times x squared, all divided by x plus 1, raised to the fourth power. And now for the second piece, we are going to use the quotient rule. So we have our bottom term, x plus 1, times the derivative of our top term, which is 2x, minus our top term, times the derivative of our bottom term. The derivative of x plus 1 is just 1, so we multiply that by 1. And then all of this gets divided by the bottom term squared. Let's go ahead and let's see if we can clean this up. This is 5 x squared over x plus 1 to the fourth. In the numerator, we have 2x squared plus 2x minus x squared. And then in our denominator, we have x plus 1 squared. Now we have to combine everything. For this first term, let's go ahead and let's multiply it out, because notice that we have an x plus 1 in the denominator of both of these terms, and we're going to need to combine that. So we're going to write this as 5 times x squared to the fourth. You just take the exponents and you multiply them. So 2 times 4 is 8. And then in the denominator, we have an x plus 1 to the fourth. And then for our second piece, we have 2x squared minus x squared. So that's x squared plus 2x, all divided by x plus 1 squared. This gives us 5x to the 8th, and then the x squared plus 2x. Let me highlight that so you can see what I'm talking about. For that piece, we can pull out an x and write this as x plus 2. And then in our denominator, we have two functions multiplied, which means we add the exponents. So this becomes x plus 1 to the 6th. Now we're almost done. We can combine our x's. So we have a 5x to the 9th and we have an x plus 2. And in our denominator, we have our x plus 1 to the 6th power. And that is our final answer. Hang with me, we have one more to do, and it's different because it involves trig functions, and it also has an inner, middle, and outer term. Here's our fourth example. We are going to take the derivative of sine of cosine of tangent x. Since this function has an inner term, a middle term, and an outer term, I went ahead and wrote down the formula for our derivative. It is going to be the derivative of the outside function times the derivative of the middle function times the derivative of the inside function. Our derivative is going to be f prime of x. The derivative of the outside function is the derivative of sine, which is cosine. So we have cosine of tangent x. Now we're going to multiply by the derivative of the middle function, which is our cosine. The derivative of cosine is minus sine, and inside that function is tangent x. And then lastly, we're going to multiply by the derivative of the inner function, which is tangent. The derivative of tangent x is secant squared x. Now we're going to rewrite all of this, and we are going to put our function that just has one piece first, and then the one that has two pieces, and then the one that has three pieces. So we write this as minus secant squared x times sine of tangent x times cosine of tangent x. And that's our derivative.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.